So I'll start with a little bit of introduction of myself and the project. My name is Vince. I co-founded zk.Link in the year 2021. We started as one of the early teams to work on interoperability using zero-knowledge proofs. Back in 2021, we imagined that the future of Ethereum ecosystem we might see multiple layer 2s. At that time, a lot of people still not convinced of the feasibility or implementation of zk EVMs, zk VMs, and we imagined this. And now today, our idea has already been validated by the market, and we're already seeing the emerging layer 2s. There's probably gonna be hundreds of layer 2s, and all these layer 2s going to lead to a critical problem of liquidity fragmentation across the layer 2s. So now people are thinking about solutions, how to address to liquidity fragmentation and how to make layer 2s interoperable. So zk.Link comes with our solution, our answer, which is zk.Link Nexus, the first ZKP-based multi-rollup layer 3. I just want to emphasize a little bit on the keywords. First, it is a zero-knowledge proof-based layer 3. So we're building our ZK rollup, a layer 3, on top of other ZK rollups, layer 2s. And it is unified layer 3. So it's one layer 3 for multiple layer 2s. So you have one unified layer 3 speaking to different layer 2s, including the ones that we already know, Stucknet, ZK Sync of different runtimes, virtual machine, Stucknet as Carol VM, and the others have ZK EVM, and potentially we will see more ZK VM maybe coming up. So I guess most of us already have heard about what a layer 3 is trying to do and what they are. So basically, in a nutshell, layer 3 is a third layer built on top of layer 2s, and they post the proofs and transactions and settle the transactions on layer 2s. Or there's some of the implementation that can also post to layer 1s directly to allow funds enter layer 3 directly from layer 1, which is one feature of our design. And it comes with higher scalability in the sense that you have self-sovereignty over all the resources available in the layer 3. So it is application-specific approach. So people also say it's app chains, app rollups, and it delivers almost the same level of security. If we think that the layer 2s are equivalent to this Ethereum security, then we, if using ZKP, layer 3s inherited layer 2s, and the layer 2s inherit layer 1s, and eventually layer 3s inherit security from layer 1. And it comes with more application-specific customizability because it's application-specific. So you are able to deploy layer 3s in a modular manner that you can select the network collection, the underlying, which layer 2s you need, and also where you want to put the data code data availability on. You can use one of the underlying layer 2s, you can use layer 1, you can use modular solution like Celestia or EigenDA, which I'm going to talk a little bit later. And the customizability also means that there are other setups and the parameters. These can be customizable, which I'm going to mention just now. The major difference between other layer 3 solutions and the zk.Link Nexus is that we're sitting on top of multiple layer 2s. And while the Stucknet Madara is a scaling layer 3 engine only for Stucknet Carol VM, and the ZK Sync hyperchains are for ZK Sync Stack, and Arbitrum Orbit is also within Arbitrum layer 2, and they share the resource of these respective layer 2s. They cannot directly talk to each other. They don't speak to the liquidities, or they have to use a bridge. And the zk.Link is a unified layer 3, so you can aggregate the native liquidities and assets across layer 2s. And also, it comes with cross-layer 3 rollup composability, so it means that so this is not a unique feature. The composability is the same for the other single rollup layer 3s. And it is, I think the most important feature of it is that it aggregates assets and liquidities from the layer 2, so it solves the fragmentation problem. And we also provide some features we have developed specifically for our use cases, including multi-application recursive proof verification to reduce the amount of gas cost when you verify the zero-knowledge proof on layer 2s. And we are developing a trading-specific, domain-specific language. It's a TypeScript to allow DEX builders to offer more feature-rich product to enable algo trading, such as, and also copy trading, social trading, yes, etc. As zk.Link is building infrastructure specifically for trading applications, so we're going very deep to offer as much as possible the features that the pro traders want, the retailers want. This is the graphic showing how layer 3s are inheriting security from layer 1. Especially when it comes to a multi-rollup or multi-chain infrastructure, the first thing we have to deal with is the challenge of security, states consistency across different rollups and chains, because they cannot perceive the states directly from each other. So this poses the challenge of deposit fraud. For example, the validator can tell one chain or one rollup. For example, the validator of zk.Link can tell zk.Sync there's 100 USDT deposit on Stacknet, but the zk.Sync contract cannot verify that. They need to trust the validator in this sense. And then same, Linear can receive deposit information from zk.Sync they cannot verify. How can they verify this? Our solution is that they post the states root that they received from the layer 3 to Ethereum layer 1 contract. So basically you have Ethereum layer 1 contract to verify the consistencies of the state roots they received from different layer 2s through the official bridge. So, and then they will return these results to the contracts on layer 2s, and then you achieve the consistency of states across layer 2s. So deposit fraud won't be possible because the layer 2s will verify the proof, and then the smart contract on layer 1 on Ethereum will verify the state's proof, the state's consistency, because there's only one Merkle tree on layer 3. So this is the way we solve the deposit fraud problem. Yeah, this is just like I explained. So this is possible to inherit the Ethereum security layer 3 when you build a multi-rollup infrastructure. This is the breakdown of the system components. Not everything is here. You have the major components here. Layer 1, layer 2s, and zk.Link Nexus. Yeah, we have the standard watcher, server, executor, prover. The validators can be decentralized, and the prover network can be decentralized as well. There are two options for the sequencers. One application, one layer 3. You don't need decentralized sequencer because all the transactions is already comes with sequence. But if you have multiple, if you have you want to compose transactions, you want to have a shared sequencing service, it's also possible. So you can compose the transactions across multiple applications. This could potentially be beneficial for certain types of transactions. And also you allow the tokens to transfer directly from one layer 3 application to the other. So you have a certain sort of composability. And then also there's a public-private RPC service. We provide the SDKs, API SDK for the layer 3 the application builders to call the service. So which means that the application builders using zk.Link Infra wouldn't have to program a smart contract. They just use the APIs, and the APIs will allow them to access to the layer 2 blockchain and layer 1 blockchain. We also have a few type of specific key functions to simplify the application builder's dev work. We embed a AA-based MPC and account abstraction-based ZK social login to provide CEX equivalent deposit user experience. It means that you can directly deposit to your zk.Link application from Binance account without having to know which chain it is, without having to use a gas token or buy a gas token. This is greatly simplified user experience. We consider this to be a very important feature to be able to onboard CEX users to DEX. And we are also providing Oracle Hub. The Oracle Hub major purpose is to aggregate the price feeds of chain and then prove these price feeds with zero-knowledge proof, and then you'll be able to verify the price feeds signature on the smart contract one time instead of 100 times. You will be able to save a lot of cost for that. And then if you're already aggregating the price feeds from several different Oracle, the application builders will be entitled with certain programmable capability to come up with price filtering features to protect the local market. So for example, when recently we have seen the fake news of Cointelegraph that have evaporated $100 million over 30 minutes, some DEXs can come up with a price filtering mechanism to protect such instance, to protect the traders. This could be beneficial for derivatives, for perpetual contract trading. And the third key function is adaptive liquidity rebalancing. As you were building across rollup infrastructure, so liquidity we're already seeing liquidity moving from one direction to the other, especially when there's market campaigns, there are airdrops, or there's a new popular application, then a lot of users will flow suddenly from one layer 2 to another layer 2, one blockchain to another one. Then you need tools to rebalance liquidities, because the users can at any moment they want to withdraw to any of the underlying layer 2s, and you would want to allow that to happen. So we provide SDKs for developers to manage this easily. And a liquidity broker service is also needed for layer 2, layer 3s, because layer 2, layer 3's finality nowadays is still not good enough to have a smooth, seamless user experience. As a user, especially, I want to trade, and when I make a profit, I want to exit, and I have other needs for the funds. I would want to exit immediately. Then you need brokers to provide the funds, and we will also provide a SDK for that. So this, again, all these 4 features are to simplify the dev work of our application builders. They can do it themselves, but with these SDKs, it's a lot easier for them. Now, layer 3s are also modular architecture, so you can always choose where to put the data availability. And for zk.Link Nexus, you have the additional flexibility of the network selections. This can potentially satisfy diverse demands of different types of applications or different demographic regions. For example, you can say that I want zk Sync, I want a Stacknet, I want a Scroll. And another tab may say, okay, I also want, for example, Polygon zk EVM, or I want another new zk EVM, maybe Kakarot or Tycho, for example, right? So you can have different collections of the underlying layer 2s, and also it's possible to include the optimistic layer 2s into the connection as well. But this, you would introduce additional component to accelerate the communication between the layer 2 and the Ethereum layer 1. Because now, with the 7 days delay of the finality time, it is intolerable for the application users. So you need a messenger service to send the state route to Ethereum from Arbitrum, from Optimism. For example, you can use a generic messaging service. It's not difficult to implement. It's just that by design, it's less theoretically secure as the ZK ROB layer 2s. And for DA, there are different options depending on the cost you can tolerate and the security you want. we are developing internally a new type of DA deployment. We call it a data retrievability DA. So it focuses on the assets retrievability, because for trading applications, the data structure is pretty simple. On the leaves of the Merkle tree, you know what types of what assets, you know the specific meaning of the data on the leaf nodes. So it's possible to have a smaller amount of DA stored on chain, and you make sure that whenever and whatever happens, you can get that DA and restore the states and get user funds back. Then it's so, compared with general purpose layer 2s, it can significantly reduce the amount of DA needed, because on a general purpose layer 2 state tree, you don't know the meaning, specific meaning of the leaf nodes. So this is one thing we're exploring, and now we probably will publish this once it's ready. For being a layer 3 compared with layer 2s, how are layer 3s gonna be compete with layer 2s? Because we face the same problem, limited developer resource, developer community, limited attention, limited bandwidth. So layer 3s to compete with general purpose layer 2s has to have better performance and a lower cost. It has to come with very obvious advantages that solve real problems of developers, because layer 2s in general have a higher, a bigger voice and a bigger ecosystem. So there are a lot of advantages that layer 3s cannot provide. Hence, layer 3s has to be competitive in terms of performance and cost. We have done a few types of optimizations to improve the performance. Most of work is focused on the circuit executors, refactoring. Also parallelize the processing process, parallelize the process of the data, witness generation, and the server core. Also, we're still quite early, but we are doing some pioneering work on the efficient proof system. Recently, we are doing internal benchmark of Supernova. And the Supernova, the folding scheme, has shown very positive results in proof generation. It could improve the proof generation by order of magnitude, but the implementation is still early. And we're also doing studies on Halo 2 for IVC purpose. It's more IVC incremental verification. It's more friendly. We hope to be able to open source our work on the implementation of Supernova. So we have a community builder to contribute to this, and this will be beneficial for the whole industry. This is the multi-application recursive proof verification. Layer 2s already have this. This is to aggregate the proofs, and you reduce the amount of times for example, we can aggregate 4 proofs into one, 8 proofs into one, so this will save cost of on-chain verification. Until today, the on-chain verification still takes most of the operational cost of ZK rollup. So if we can reduce the verification times, this will be a lot more cost effective. For trading specific DSL, it's important for the decentralized trading application builders, because now the DEXs we see are mostly they represented by 2 groups, AMM model and order book model. And order book models were still early, exploring how to provide all these product features we have seen on centralized platforms. And with this DSL, it will be a lot easier for the builders to migrate these features and compete with CEXs. If we are able to provide these features on the DEX, this will help to migrate users from the CEX to DEXs. The most important benefits of the infrastructure solution we're providing is the token assets aggregation and liquidity unification. So the same token from different layer 2s can be merged into the single token on the layer 3. So for example, for stables and Ethereum, this will simplify the user experience and also potentially will be beneficial for traders, right? So they can maximize their capital efficiency. And also you can list different assets from different ecosystems on one user interface without having to use a bridge. Again, this is a simplified user experience. Abstracted user experience. Simplification is important for mass adoption. Yeah, this is the end of the presentation. If you want to know more in detail of how to utilize the infra, welcome to visit our website and feel free to follow us on Twitter. Thank you very much. Maybe do we have time for like quick Q&A? Yeah.
Thanks for the talk. Is it in mainnet? Or how far away from mainnet are you?
For Nexus, we're on testnet. But we have another, I didn't speak of our alpha mainnet solution layer 2.5, which emphasizes more on connectivity with layer 1s, layer 2s difference. The zk.Link origin is connected with Ethereum and EVM outer layer 1s like BNB chain. That one is already live.
Because some of the things
this one's on testnet, sorry.
Some of the things you were talking about are really scary. The part of you providing different proofs to different L2s and not being
Same proof, not different proofs.
A malicious validator can provide different proofs to different L2s. And you have hard time collecting them kind of together.
It's the same proof.
If it's malicious, it can do different.
Yes, but then you cannot achieve the status synchronization on Ethereum.
But that's going to happen half an hour later. So
probably longer than that.
Oh, even longer.
Yeah, probably longer than that.
So, the horse is out of the barn by now.
But then the users will not be able to withdraw the funds. The funds will only be, you can only withdraw the funds after the synchronization of states.
And the second thing is, so this means that a single L2 failing blocks all the stuff.
True. Yes. So you have to be careful with which layer 2s you want to select. Yeah, true. Any more questions? But as it is application specific, so this only affects one application. It's not a contagious. Yeah. This is the limits of layer 3, and also this probably, at the same time, make this problem less complicated because it's application specific. Thank you very much.